And welcome back, ladies and gentlemen. It's Mr. Callen here to help you with Chapter 2, Lessons 6 and 7, more dividing decimals, more decimal quotients. Hey, go ahead, pause your video, check your answers, please. Odds were in the back of the book, so you really only need to check evens. When you come back, we will continue. I'll be looking for questions the next time we are together. Meanwhile, our objective for today, I will divide decimals by decimals. Yesterday, we were dividing decimals by whole numbers. Then we will continue on using a shortcut to divide powers of 10. We've used a shortcut to multiply by powers of 10. We're going to eventually divide. Don't forget that we will also be moving towards using quotients of decimals in more complicated algebra like algebraic equations that you see. When you're ready, pause your paper. Go ahead and look up at the top. Name, date, period, please. Page 41 and page 43. Assignment number 11 called Computing Decimal Quotients. Now, don't forget, I'll remind you of this at the end. We are going to remind you, hey, don't forget, write the directions, then write the number and the problem and the work, and then finally your answer. Now, there are exceptions. Don't forget, for word problems, you do not need to write the problem. If that is the case, then you will simply write the directions and then the work and your answer. More pressing for today for problems 21 through 36 on page 43. That's asking you to use mental math, so I will expect you to write the directions, the problem, and your answer, and not write the work. All right, pause. When you're ready to come back, come back. And here we go. Now, really, when it comes to the division of fractions, I need you to focus on 1. That might sound a little weird, but I need you to focus on 1. If I were to write this division, well, let's try to get off of Magic Pen, Mr. Callen. If I were to write this division, 40 and 1200ths divided by 0 and 800ths, as a quotient, I want you to recognize one thing, that if I asked you to multiply times 1, we're not really changing anything, are we? What I could do, however, is say, well, 1 whole is the same as 10 over 10. Why does that help us? Because we know from what we learned last week that we can move the decimal point over to make 401 and 2/10 divided by 8/10. You know what? Let's keep going one more time. I really don't want a decimal quotient. So if I instead then multiply by 100 over 100, again, that's still 1 whole, I'm not really changing the problem, but I will get the same answer. So anytime we're dividing by decimals, our main focus is change the divisor to a whole number. As long as you are fair to the dividend, you will not mess up the problem. In other words, we're going to now divide 4012 by 8. Now, 8 does not go into 4. It does go into 45 times with no remainder. Lovely. Let's bring a 1 down. 8 does not go into 1. So we can bring a 2 down. 8 does go into 12 one time. Uh-oh. Oh, that's okay. We learned this the other day. Remember, you may add as many zeros as you want. We still have 4012 split up into 8 parts. So let's go ahead and bring that 0 down and look at there. It goes in quite lovely. Final answer will be 501 and 5/10. Now again, if I were to write this division problem as a fraction, and if we multiply by 10/10, well, that's still got a decimal down below. So let's multiply by 100 100. Remember, that is still 1 whole. We're not changing the problem. But now it is no longer going to be a decimal divisor. It'll be 35. But of course, we must be fair to the numerator, put in a 0. We're going to do 140 split up. So once again, as I said before, anytime you are dividing and the divisor is a decimal, Let's change it to a whole number as long as we're fair. Why does that work? Because essentially all we're doing is multiplying by one whole. We're not really changing the problem. Now 35 does not go into 1, it does not go into 14, but it does go into 140 actually quite nicely, ladies and gents. So the final answer is actually 4 wholes. All right, that should review a little what you learned in 6th grade. Let's go on with a shortcut. Anytime you multiply by powers of 10, if you remember when we multiplied by powers of 10, it really enlarged the number, and so we could move the decimal point to the right. Well, you can use your logic then to say, all right, what happens to the decimal when we divide by a power of 10? Instead of enlarging, it's going to shrink. And if there's 1 0, we're going to move it to the left 1 place. If there are 2 zeros, we're going to move it to the left 2 places. You will move the decimal point to the left, however many zeros there are. And so if we divide 47 and 1500ths by 10, final answer would be 4 wholes, 715 thousandths. If we divide the same number by 100 with 2 zeros, we'll move it 2 decimal places and get to no wholes, and 4,715 ten thousandths. If there are 3 zeros, you guessed it, 1, 2, and 3 decimal places, you got to hold that decimal place with a 0. So we still have 4,715 parts, but now this is tenths, hundredths, that 1,000s, 10,000s, 100,000ths. 4,715 100,000ths. That's what I have for today, ladies and gents. Go ahead back to your page. Just remember, please, hopefully you just squeezed in some examples on your paper. So if you draw a line directly under your examples, make sure that you are writing the directions. In this case, it's divide, whatever the directions are. Make sure you're writing the problem. Make sure you are showing your work, and you can write your answer either up above or down below. It doesn't really matter to me. Just don't forget, once you get to page 43, that's going to be no work shown. So you'll write the directions, the problem, skip the work, and go straight to the answer. Folks, I'm looking forward to seeing you again. Take care, do well, and let's grow.